Okay, with radians instead of degrees, now we got the radian column on that sheet, but again, we've got all these radian measures. We got 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6 pi, and so on in that order. It doesn't seem like there's any rhyme or reason to that, right? It just kind of seems like it's just jumping around. The thing is, there's pi over 6, pi over 4, pi over 3, pi over 2, and then again 2 pi over 3 and so on. The denominators are always going to be 2, 3, 4, and 6 if there's any fractions whatsoever. And keeping in mind that if we are too big, we have to subtract. So obviously between 0 and 360 is pretty obvious. Something bigger than 360, got to subtract 360. With fractions, it's not quite as obvious, right? All right, the range is from 0 to 2 pi. Now what I want you to recognize about 2 pi is 2 pi is the same as 4 pi over 2. It's the same as 6 pi over 3. It's the same as 8 pi over 4. It's the same as 10 pi over 5, which we don't care about because that's not one of our denominators, right? And then 12 pi over 6. Each of these fractions is equivalent to 2 pi, right? So each of these fractions is going to be helpful in determining two things. Number one, is the angle too big? And number two, what should I add or subtract? Because when we add or subtract fractions, we should be adding and subtracting with a common denominator. So looking at 17 pi over 4, anything between 0 and 8 pi over 4 is fine, right? Mm-hmm. 8 pi over 4, 17 pi over 4 is too big. So I need to subtract 2 pi, which is the same as subtracting 8 pi over 4. So minus 8 pi over 4 gets me to cosine of 9 pi over 4. I can see 9 pi over 4 is still too big. Subtract 8 pi over 4 again, and that gets me to cosine of pi over 4. At this point, pi over 4 is between 0 and 8 pi over 4, right? Mm-hmm. So now I'm able to go to my sheet. I find the pi over 4 radian measure. I scroll on over to the cosine, and I notice that's the square root of 2 over 2. That's exactly the same question as problem B on the first one. It was cosine of 45 degrees. 45 degrees and pi over 4 radians are the same. So it happens to be the same answer. Looking at cosecant of 4 pi over 3, again, in the pi over 3 area, we got to go between 0 and 6 pi over 3. We can see very clearly 4 pi over 3 is between 0 and 6 pi over 3, right? So we're in good shape there. Cosecant would be negative 2 times the square root of 3 over 3. All right? So again, if you find 4 pi over 3, and you go over the cosecant column, look down, look across, that's where they intersect, that's the answer to the problem. That's how I want you to do those exact value problems for right now. Get the angle in between 0 and 360, or between 0 and 2 pi, or some fractional version of 2 pi. Okay? And then once you find the correct radian or degree measure, it'll be right there on the sheet. Every exact value that we're going to be dealing with at this moment in time will be there. Okay? There's only one other section involving exact values down the road. That would be multiples of 15. They have some exact values also, but you have to use the exact values on that sheet to create the exact values of the multiples of 15. So we don't have to memorize those, but just know that that's the only other place we're going to be getting the exact values in relation to trigonometric functions.